Next thing that we're going to take a look at is how do we use right angle trigonometry and primary trig ratios to solve for a right angle triangle that has an unknown side length. So what we'll do is we'll draw an example. Okay, so again, it's a right angle triangle, just so we can see that because it's got the right angle symbol in there. Okay, and let's say, for example, that this angle here is 30 degrees. This is x, and this happens to be 20. Okay, or try and make that look like a proper 20 so that we're not confusing people. Okay. So again, first thing that we always need to do with right angle trigonometry is label our HOA. We always need to label the three sides. Okay. So we can always start off by labeling the hypotenuse, because the hypotenuse is always equal to, or the side across from the right angle. The opposite is the side length across from the angle, or opposite the angle. So this is my opposite side. And therefore, my final piece here, this must therefore be my adjacent. So now that I've labeled my HOA, I can go back and I can figure out, well, which of my primary trig ratios do I need to use? So in order to decipher which primary trig ratio you want to use, I suggest actually writing out the word or the term SOHCAHTOA. Okay? So what is it that we're looking for? Well, we're looking for the opposite. We don't know what that x value is, and we know that the x value is on the opposite side. So I'm going to underline my opposites. Okay? So right now, I know that I can either use the sine ratio or the tangent ratio because both of them will help me to find the opposite. I cannot use the cos ratio because it doesn't have anything to do with the opposite. So the next thing I want to identify is what other information do I have? Well, I have a hypotenuse, so I'm going to put a check mark above the hypotenuse. And I also have an angle. In this case, my angle is 30 degrees. Okay? So you need to have two of the three pieces of information, and it has to let you solve what you're looking for. So in this particular instance, the ratio that I want to use is going to be the sine ratio. So I'm going to set this up. I've got sine of an angle, or sine theta, is equal to the opposite divided by the hypotenuse. So now I'm going to substitute in the values that I know. I know that my angle is 30 degrees, so sine of 30 degrees is equal to the opposite, in this case x, over the hypotenuse, and the hypotenuse is equal to 20. Okay, so now we need to go through and solve. Okay, and again, sine 30 just represents a number. In fact, if you plug sine 30 into your calculator, it'll give you some decimal number. Just quickly, if I plug it into my calculator, I get 0.45 and a bunch of decimals thereafter. Okay, so bear in mind that any number can be written as a fraction, and sine 30 is no different. So I'm going to write this as a fraction over 1. So now I just have a simple proportion. I've got a ratio. And in order to solve the ratio, you need to do cross multiplying. So I'm going to do x times 1. That just leaves me with x. And I'm going to do sine 30 times 20. Okay. And sine 30 times 20 is going to leave me with, or rather, 20 times sine 30 degrees. So x is going to end up equaling approximately 11.5 units. Okay, so the key here is that you got to do your cross multiplying piece. Okay. So let's do another example for a SOHCAHTOA with an unknown side. So in this case, I've got another triangle. Okay, now my triangle is going to be labeled, I've got this as being 30 degrees up here. This side is going to be 12. Okay, and I don't know what that value is. Okay, so again, first thing I always need to do is label my three sides with my HOA. So side across from the right angle, that's my hypotenuse. Then the side across from the angle, that's my opposite side. Okay, so therefore, the remaining side must be my adjacent side. So if I go through and I write out my SOHCAHTOA, okay, I am looking for my hypotenuse. So I'm going to underline hypotenuse. So by knowing that I'm having to find the hypotenuse, that automatically eliminates the tan ratio. So what else what other piece of information do I have? Well, I know the angle is 30 degrees, so I can put a check mark over the sine and the cosine piece. Okay, S, C, and T all represent the angle. Okay, so I know those two things. And in this case, I know the value of my adjacent side. So therefore, I have to use the cosine ratio. So if I go through and I use my cosine ratio is cos theta, or cos of some angle, is equal to the adjacent side divided by the hypotenuse. Now I'm going to substitute values in. So cos of 30 degrees is equal to 12 over x. Okay, and again, I need to do my cross multiplying, and again, any number can be written as a fraction. So I can do cross multiplying. I can do 1 times 12. Okay, and I can do cos 30 times x. So that's going to give me x times cos 30 degrees is equal to 12 times 1, which is just 12. Okay, and I want to get x all by itself. So that means that I have to divide both sides by this cos 30 degrees. Okay, so I'm going to divide both sides by cos 30, and that's going to end up giving me x is equal to approximately 13.9 units long. Okay, so in those two examples, I've shown you how you can use right angle trigonometry to figure out the unknown side length for a right angle triangle using primary trig ratios.